Good morning. This is Eric Valenzuela. Thank you for joining us today on this webinar. I am the Senior Director of Business Development and Cloud Services for the North America region at Beyondsoft. I'm also joined here by Jeremy Winters, our esteemed Principal Software Engineer and Data Solutions Architect. Jeremy is also the creator of Converge DB. We're really excited today to have you on to speak about Beyondsoft briefly, and then also to dig into the power and the capability of Converge DB. Converge DB is a tool that we introduced that we like to say is DevOps for data. And this is actually something that can be used by any company that has a cloud presence, wants to move to the cloud. We're doing analytics and analysis. Beyondsoft is also an Amazon advanced consulting partner. So we have a wide range of consulting products and services that we consult on. Things like cloud data solutions, DevOps, serverless, machine learning and AI, also microservices. So without too much delay, let's go ahead and pass it over to Jeremy so we can dig into Converge DB, and then also get a preview for the tool itself as a demo.
Thanks, Eric. Yeah, this is Jeremy Winters. So let's just jump right into what is Converge DB. So at its core, Converge DB is a codified set of best practices for building and managing cloud-based data lakes. It's also free open source software. It's, we call it DevOps for data for many reasons, but one of the key reasons is that the file-based approach is very friendly for use in source control systems and can be easily integrated into continuous integration or continuous deployment pipelines. An interesting point is that Converge DB sits outside of your data lake, translating your requirements into code and other deployable artifacts that are needed to run in the cloud. So it's not something you install in the cloud and run. It's something that you use outside of the cloud to design your data lake effectively. So the target users for Converge DB, we have two primary groups. The first is teams that are using DevOps methodologies to manage all aspects of their cloud applications, but they're feeling the pain of trying to manage the analytics platform using those DevOps methodologies. And on the other side are the data experts in the organization who understand the data really better than anybody else in the organization, but they don't necessarily know how to create the code necessary to utilize the latest technologies. So let me take you through a real customer use case. This is our first customer that just went into production a couple weeks ago. Our customer had the following data flowing into S3, with log data from web applications, approximately 40,000 files per day of JSON data, gzip compressed. So, querying this data directly is not performant because the data coming out of their systems is not partitioned, and JSON data is inefficient for direct querying with Hadoop-based query tools. It's possible. It just doesn't perform as well as it could, and and sometimes can cause these, cause timeouts and stuff like that. So our customer required an analytics system for their customer support efforts with the following qualities: high-performing queries for sporadic workloads with a minimal cost. So this means that, maybe one day they don't use it at all. Maybe the next day they use, 100 queries. It really, their workloads are very sporadic because they're in response to customer needs. The solution should also be low touch with a light learning curve in order to be supported by their already stretched engineering team. So their engineers are very bright and capable of, figuring out how to build a data lake themselves. They just don't have the bandwidth to dive in and learn all the details and the subtleties of the technology. And of course, the system should scale to, optimistic business growth. Every company, wants to see huge growth and be able to plan for it and to be ready for it. So that was one of the requirements of their system as well. So here's the key technologies involved in a Converge DB deployment. Converge DB uses cloud services such as Amazon S3, the simple storage service. A lot of you have probably already heard of S3, but for those who haven't, S3 is a distributed object store. Essentially, it's like having a giant SFTP server in the cloud with unlimited capacity that backs up every file the moment that it's written. Amazon touts that S3 has 11 nines of uptime, which is 99 and then 9 nines of percent uptime. So it's a very, very, very reliable service, just for storing files in the cloud. Amazon Athena is another service that we use, and it is serverless implementation of Presto. And this allows end users to run SQL queries against data lakes that utilize S3 as the storage backend. Athena charges $5 for every terabyte of data scanned at query time. So again, with Athena, you put your data into S3, you connect to Athena and then run SQL queries in Athena. Then Athena goes to S3 and pulls the results out of your data files. You don't need your data loaded into a database. You just need your data sitting in S3 with the appropriate structure. The other cloud tool that we're using is AWS Glue. This is a serverless implementation of Apache Spark, and it provides the ability to execute Spark ETL scripts in a serverless environment where you pay only for the time and processing power used while your job is running. So for, a lot of times with ETL, you'll have a nightly batch that maybe runs for 3 or 4 hours. If you're using a traditional ETL solution, you might have these, 2 or 3 servers running 24 hours a day, even though they actually only do work for 2 or 3 hours a day. With a serverless solution, you're only provisioning computing power for the duration of your ETL job, and then once your ETL job is done, you're not incurring any charges. A couple of key data formats that we'll be talking about in the demo is JSON, which is an ubiquitous data format that's easy to generate for most programming languages and systems. JSON is actually a great format for source data because it is extremely flexible, but it is a bit inefficient to query the JSON files directly. Parquet is a columnar storage file format that lends itself well to optimize reading. So Parquet works well with SQL-based query tools such as Athena, Spark, Presto, and Redshift Spectrum. Parquet is an open source format. It's actually Apache Parquet. It's very interesting technology. I definitely suggest reading into it to understand why Parquet is such an efficient format for queries with SQL-based tools. So DevOps technology that we're using, ConvergDB, it piggybacks very heavily on Terraform. Terraform was created by HashiCorp and is also a free open source tool for managing infrastructure as code. ConvergDB leverages Terraform to do the heavy lifting of building the cloud infrastructure for your data lake. As a ConvergDB user, you will need to run Terraform, but you will not need to learn how to build Terraform scripts if that's something that you don't want to learn how to do. Just a note, again, we're all about doing everything serverless with ConvergDB. Terraform is not an application that you need to run continuously in the cloud or install on a server. It is just it's a command line utility that you would use on your computer or use in your CI/CD pipeline. You do not need to install Terraform, and you do not need to pay for an enterprise Terraform service. That is available, but it is not necessary. You can absolutely use the free open source version of Terraform with ConvergDB. So here's how ConvergDB works. We start with 2 files. The first is a schema file containing our table definitions, and the second is a deployment file mapping our tables to the cloud resources. These 2 files comprise what we call your ConvergDB configuration. We will review the file contents a bit later in this demo. So the configuration files are processed by the ConvergDB binary. It's a Java-based command line application. Again, you do not need to run this in the cloud. You use this locally on your laptop or desktop, or you run it in a DevOps pipeline. So ConvergDB creates, the ConvergDB.binary creates PySpark code that runs in AWS Glue ETL jobs. And it also creates the database and table definitions for querying via Amazon Athena. So again, ConvergDB actually generates the scripts that will be deployed into the cloud. Terraform is used to deploy the objects to their respective AWS services. So when we run Terraform, it'll actually upload your PySpark script into a defined Glue ETL job, take your table definition, and build an Athena table in AWS. And in addition to to pushing these artifacts up there, it will build all of the supporting cloud infrastructure, such as access policies and S3 buckets, things like that that are necessary to manage your data lake end to end. So at this point, once you've run Terraform for your ConvergDB configuration, you will have deployed a serverless ETL application. It will take your JSON data in one S3 bucket, run it through an AWS Glue job, and convert it to Parquet in another. At that point, it'll be exposed via AWS Athena to your end users for SQL querying. Okay, and this just kind of shows, this last one really just sort of shows the data flowing through. So here is a slightly more detailed diagram that highlights the flow a little bit better and kind of explains some of the sweeteners, the extra features that you'll get from ConvergDB. So the way this diagram is divided, on the left side is what I call the source control managed workflow. This could be on your local machine, or it could be in a DevOps pipeline. On the right side is your actual cloud environment, what you actually have running in Amazon Web Services. So again, you'll see over on the left, we have the files defined by the user, which is the schema file and the deployment file. You run those through the ConvergDB binary. The ConvergDB binary outputs PySpark scripts, a Terraform configuration, and the table definitions. Terraform is then used to access the AWS APIs to deploy all of these objects into AWS for you. So we have our Glue ETL job, which takes the JSON data and turns it into Parquet. In addition to leveraging AWS Glue, the custom PySpark script also adds additional operational features such as notifications to Amazon Simple Notification Service whenever a job succeeds or a job fails. This is useful for running into your Slack channels or PagerDuty, stuff like that. It also creates CloudWatch metrics and even CloudWatch metrics dashboards to monitor how much data is flowing through your data lake, how many job failures, how many job successes. It really just gives a very easy way to monitor what's happening in your ETL environment. Because ConvergDB leverages the Glue catalog, which allows you to store your table definitions and make them available to pretty much any Hadoop application, you really have instant support for Amazon Athena as well as Redshift Spectrum. So again, once you build your data lake tables with ConvergDB, you can connect immediately with Redshift Spectrum, and in about 15 to 20 seconds, you'll be querying data from your ConvergDB data lake. Or, of course, you can use AWS Athena and write queries in the AWS console. Here's some of the key features and capabilities of ConvergDB. So the first is that it is open source software. ConvergDB is released with the AGPL v3 license, allowing you to use it 100% for free. The serverless architecture is where, for one thing, makes it easier to secure your data lake because you don't have servers running that you have to manage access to or SSH keys. You really just have to manage interactions between AWS services, which are just fundamentally easier to secure. And of course, with a serverless infrastructure, you only get charged for the cloud resources that you need to process your data. You're not incurring charges unless you're doing something. Another key feature of ConvergDB is that we do auto batching of large data sets. So let's say you have a terabyte of data, but you only have 100 gigabytes of RAM in your Glue cluster, ConvergDB is not going to try to process that terabyte of data at one time. Instead, it's going to break it into 100 gigabyte chunks and do just process one chunk at a time, one small batch at a time. And let's say after 10 hours or 20 hours, one of your batches fails, you'll only lose one or 2 hours of paid compute time. You won't lose 20 hours of compute time, which is something that is possible with these large Spark jobs. If they fail, many hours into running the job. And depending if you don't have these batched sort of checkpoints along the way, you'll just end up having wasted all of that computing time, which could be expensive. This batching of large data sets actually, for one thing, makes the operation more efficient because it utilizes the memory as opposed to utilizing disk, but it really helps mitigate the impact, the cost impact of failures. The fact that we leverage the latest cloud services, so right now, of course, we're leveraging Glue, Athena, and Redshift Spectrum, but we also have on our roadmap to support new cloud services as they emerge. So let's say that something better than Redshift Spectrum, better than Athena comes out in the next 1 or 2 years. We will integrate it into Converge DB, and then as an end user, you can utilize this technology with only a configuration change. You will not need to do a big migration project. You'll just need to change your configuration to start leveraging the new tool. Another key feature here is that you retain total control of your data. Your data never leaves your company's cloud environment. So you are not shipping your data off to Converge DB for us to manage it for you. All of your data stays in your cloud environment, and I think this is key for a lot of compliance and security-obsessed industries. So other features, SNS notifications, batch success failure, it can be communicated to your support teams, CloudWatch metrics and dashboards. These metrics are published to let you know what are the data volumes, file counts, etc. State tracking and control table. Converge DB keeps track of the state of each table and which files have been loaded. This actually helps with the next feature, which is auto recovery after job failure. Batch failures are detected on the next ETL run, then cleaned up in order to allow for retries. This kind of goes along with one of the cloud principles of designing for failure in your applications. Assume that there's going to be failures so that you can gracefully recover from them. All right, so let's move to the demo. Before we look at any code, let me just show you what we have in our Glue console. Just one moment, let me share my screen. So in the AWS Glue console, we have one ETL job. This is not our ETL job. This is just another ETL job that exists in my environment. Let's go to the terminal. So you see here, let's do a clear, and let's have a look at our files here. So we have, look at our books files. We have a books.deployment and a books.schema. These are the schema and deployment files that were mentioned in the presentation. So let's have a look at the books.schema file. So in the books.schema file, what we've done is we've defined, we've defined a few things here. So the first is a domain and a schema. These are really just namespaces to group our relations. So domain in a traditional database would actually correlate to the database label itself. Schema correlates to schema, and relation correlates to what you would think of normally as a database table. We have two types of relations in Converge DB. The first is a base relation. A base relation is actually a definition of the data in your source files, such as your JSON files. What we're saying here is that we expect to find a JSON key labeled item number, title, author, price, and stock in the JSON documents. Once we find these items, we're going to cast them to these target data types. So even if item number is enclosed in quotes and comes through as a string, we're going to make sure that it gets treated as an integer throughout the rest of the processing. The second relation is what we refer to as a derived relation. Derived relations are sourced from a base relation, in this case, the books source, which is our base relation above. Another aspect of derived relations is that we're able to specify partitions, and these will actually be used for partitioning the data in our data lake. In this case, we're partitioning by the field called part ID. Now, looking at the attributes of the derived relation, we see these first four, item number, title, author, and price. These are just brought over as they were in the base relation. So item number in the derived relation, it's just going to be the same field value as item number in the base relation. But when we get down to part ID, while we did specify a data type, we also specified an expression. And this expression is a SQL snippet that refers to the title field in the base relation. Now, what we've done here is we've put an MD5 around the title and did a substring. And what this is going to do is give us basically a random hexadecimal number between 0 and 16. I'm sorry, 0 and 15. That's going to be used as a partitioning field. While this is definitely a contrived example, the point here is that you can synthetically generate things like partition keys, which is a very important and common transformation that you would need to do for most data sets. And you can use pretty much any SQL function that's available to you, at least common SQL functions. In addition to doing string manipulations, you can also do numeric calculations. In this case, we're just doing the math of multiplying price times 0.25. And we also have some special functions. In this case, we have one that is a Converge DB source file name. What this will do is this will actually store the file name, like the original JSON file name that a given record came from. This is the kind of thing that definitely helps with data governance as well as debugging data issues. So now let's have a look at our deployment file. So the deployment file has two stanzas. The first is a stanza defining our S3 sources, and then the second is a stanza defining our Athena table targets. So both of them are specified to be in the production environment. This is a fourth and top level of namespacing. So the relations that we have defined for our S3 source, we really just have one. This DSD field, this is a reference to the schema object for the base relation. So all we have to do is specify a fully qualified base relation here. Storage format is JSON, so we're saying that we expect to find JSON data in this S3 bucket. And as an additional optimization, this is very important for historical transformations and very large data, a very large number of files. We can actually optionally use an S3 inventory table to understand what files are available for loading from S3. So over here on the Athena side, not only have we defined a relation, but we've defined that this relation is going to be loaded by an ETL job named nightly batch, which is going to run on this cron schedule, which really we're specifying that it should run daily at midnight. The relation that we're building here, the DSD, is e-commerce inventory books. This is our derived relation that we looked at in our schema file. We're specifying to store it as a Parquet format, and we're opting to use the inventory table in order to gain the optimization of higher performing S3 inventory lookups. So that's our schema file, that's our deployment file. Now we're actually just going to use Converge DB. Takes a second to start up because this is a Java-based application, so it does have to instantiate a JVM. So what this command does is it analyzes everything in your Converge DB configuration, and it also connects to AWS to identify any differences in what you have currently deployed in AWS and what you've defined in your configuration. So in this case, we have not yet built an ETL job in Glue called nightly batch. If we look over in the AWS console, we have an AdTech ETL job, but we do not have a nightly batch job created yet. So it indicates there is no job in Glue currently that is in our configuration, but we plan to build one. There's also no relations in Athena from our configuration, but we plan to build one. For every relation that gets built in Converge DB, we output a summary of what are the differences between the current state and the target state. So in this case, it's a brand new relation, so everything is plus signs in green, indicating that all of these attributes are going to be added. If we were making changes or removing something, you might see red minuses indicating that we're not that we're taking something away or changing an attribute. So now that we have run Converge DB, let's have a look in our folder here. So we have three different folders that have been created. One of which is a Bootstrap folder, the other of which is a docs folder and a Terraform folder. So let's look quickly at the docs folder. Well, the docs folder, this folder really, it contains documentation for every relation that gets managed by Converge DB. So if we look at the HTML version of our documentation, it's very simple, but it gives you a good summary of this relation. What are the expressions used to populate it? Are these required fields, etc.? All of these, lend themselves really well to publishing into something like a static S3 website, or you can even, use the markdown files that are in the directory, these MD files, and expose them through GitHub, in your repository, your source control repository, where you check your files in. Your user can just go directly to that GitHub and browse to see what is the data dictionary for the data lake. So the two Terraform configurations, Bootstrap and Terraform, the Bootstrap Terraform deployment is actually used to do things like building S3 buckets where your data will be stored. The Bootstrap is something that you only really run once at the first time you build your data lake. You can modify it and run it again later, but in general you don't have to. We've set all the good defaults for how to build the infrastructure, and most of the time you'll be operating in the Terraform folder, which is your other Terraform configuration used to manage your ephemeral objects such as ETL jobs and your table definitions. So if we go into the Terraform folder, there's a bunch of stuff in here, and I don't need to go into it because as an end user, you don't need to go into it. You should not be going in and modifying this stuff. All you should be doing is running Terraform apply. So Terraform is going to parse the configuration. It's going to connect to AWS. It's going to identify everything that it needs to do in order to build out your data lake. Now, while it's running, we can actually go to the AWS console, and we should start, here we go. Our ETL job nightly batch got created. And let's see if here we go, Converge DB nightly batch. This is actually the trigger that runs on a daily basis to execute our job. So remember, we specified that in our deployment configuration. If I go to AWS Athena, now we should see that we also have our books table, so production e-commerce inventory books. Now, this table has been created. It has all of the fields we want. You'll see that part ID is partitioned, so it actually is a proper partition field. But it takes about 10 minutes or so to run an ETL job using Glue, because there's a minimum startup time in order to build the cluster. So I do have Converge DB, the same thing, deployed in another AWS region. And I can show you the query, select star from books, and you'll see that we're able to get data back from Athena for our books data. SQL queries aren't necessarily the most exciting thing. This just kind of closes the loop to show that once you build this stuff and run the ETL job, you'll be able to access your data through Athena or through Redshift Spectrum. With Athena, you can work in the AWS console, or you can connect directly with any JDBC client or application and pull data from AWS Athena. Let's go back to the slides here. Okay, so let me go over the Converge DB feature roadmap. So this diagram is showing a few things. Well, it's showing a lot of stuff. Anything that's available now has a check mark to indicate that this is what's in, these are the things I showed you in the demo. These are the technologies that are currently supported. So right now we support, S3 JSON transformation with Glue ETL into an S3 Parquet format, exposing the data through a Glue catalog table, which you can access through Athena, Redshift Spectrum, and honestly any elastic MapReduce applications such as Presto or Hive could also be used to access this data. So here's what we have now. On our roadmap, we have a lot of different plans. So one of them is to support loading into other downstream systems from the data lake. So, for example, it may be that, for your organization, it'll be more cost efficient to load a summary table of your data into a native Redshift cluster. So Converge DB plans to support this by using serverless containers, which is the new AWS Fargate service, to load the data directly from S3 into Redshift by way of Redshift Spectrum. Now, this would be great if you have, data scientists or analysts who have to create their own tables to which they'll join the data in S3. Or it may just be that you have enough users refreshing dashboards enough times that something like Athena would be cost prohibitive. Now, on the other side, you might have 1,000 users. Maybe you have 2,000 retail locations, and every day, throughout the day, all of your users are refreshing dashboards, referring to the current sales of their of their branch. So we actually suggest in situations like that not to use something like Redshift, which isn't really meant to support thousands of users, but to use something like Aurora Postgres, which, if designed correctly, could support a very high number of users doing this dashboard reporting. Beyond, just doing basic analytics and BI, we have intentions to support loading into AWS Neptune, which is the graph database service that's been provided. And really most important is that we intend to support these tools that we don't know about yet. We expect that there's going to be new data processing technologies in the next few years. And as a ConvergeDB user, you'll be able to download the latest version of ConvergeDB, indicate that in your configuration that you want to use this new technology. You run ConvergeDB, you run Terraform, and then it starts loading the data into this new tool, whatever that tool is. So this is sort of a future-proofing aspect of ConvergeDB that we're pretty excited about. We think that in the long term, this is going to be a very, very strong value for ConvergeDB users. So on the other end, we have a lot of data comes from JDBC databases. So, I'm sorry, databases that we can connect to with JDBC. So we have plans to create a producer that exports database data into S3 for loading. So again, this would be a serverless container that you specify. Here's my base relations. Here's the structure of my data. It will go to the database and create daily or hourly ETL jobs, whatever you need, to dump the data into S3 so that it can get integrated into your data lake. And a little bit further down the road, we have an idea for actually auto-generating an ingestion API and real-time SQL analytics. So using the tools like Kinesis and Lambda, we can take the definitions for your data, create a Lambda that validates incoming data to be in the correct structure, then pushing it into a Kinesis stream. Immediately, you can have Kinesis analytics, so you can get real-time insights on your data as it's coming in. And then, of course, eventually that data will make it to S3 and get ingested into your data lake. Okay, so that's really what we have for our demo. So we are opening up Q&A. You should be able to submit questions through the BrightTalk screen. So go ahead and type them in, and if we have any questions, Eric, do we have any questions?
Yeah, we have a couple questions. Good job there, Jeremy. By the way, that was a really good demo. We do have a couple questions for you. One of the questions that was thrown up from the audience is, where does ConvergeDB store the data?
Yes. Yeah, so that does get, I get people maybe a little bit confused because they're used to traditional database systems where you install the database and you load the data into it. With ConvergeDB, your data lake is your S3 data lake is the database. Converge DB is not something you load data into. It's a tool that designs your data lake for you and lets you leverage the cloud services that are best for your data to manage and store it. So for Converge DB, the primary place where data is stored is in S3 buckets in your company's Amazon account.
Okay. So what is the actual benefit of, whether now or in the future, what is the actual business benefit of storing your data in S3 or something similar?
Oh, so the business benefit, for one thing, S3 is incredibly cheap storage. It's a few cents per gigabyte per month. The more data you store, the lower the price is. You actually get automatic quantity discounts. And historically, as time goes on, Amazon has actually continually reduced the price. If I remember correctly, it was about 10 cents per gigabyte for S3 when it was first released, and now we're getting down to like 3.5 cents per gigabyte. So if you put a terabyte of data in S3, your cost for storing that data is going to continually decline. The other advantages are, really the resiliency, and there's a lot of features with S3 where you can actually back up automatically. You can archive to a service called Glacier, which provides really it's kind of like automatic tape backup, even though I don't think it uses tapes. I believe it uses powered off hard drives. But that's about 1/10 of the price of a storage. So if you have really, really high volumes of data, with S3, it's cheap to store, and you're never going to run out of space. There is no such thing as disk full. You can just put as much data there as you want, and Amazon will handle the scale for you.
That's great. Thank you. So another interesting question that we have here is approximately how much time and resources does this save? I presume that they mean the tool itself. Does this save for both the users and the companies?
So how much time and resources? So thinking in terms of, a development team, well, it really, it's hard. I'm trying to think. I've actually thought of this before. How do we quantify how much time this will save? So first of all, let's think of, let's take a quick hypothetical situation where you have a developer who understands DevOps, but only has a basic understanding of data. They know how to create a database table. They might even have some traditional SQL knowledge, maybe even, a little bit of DBA knowledge. But if they don't have, perhaps they don't have deep Python or PySpark knowledge. Maybe they don't have strong skills in using, well, actually, let's assume they're a DevOps user. So let's just focus on their lack of, let's say, programming skills. If you have this user who has never used a technology like PySpark before, besides the fact that it could take them, truly take them months just to get up to speed with learning the syntax of writing Python or PySpark, there's also going to be a lot of very subtle gotchas that come down the road. So let's even, being optimistic that if they were able to spend 2 months learning how to write the PySpark and really digging deep into how to optimize the PySpark, that's 2 months that they would not need to spend learning PySpark if they're using ConvergDB. With ConvergDB, they do not need to write PySpark at all or understand how it's written. They only need to understand what needs to be done with the data. So, my approximation is saving 2 months, assuming a person could learn to be an advanced Spark user in 2 months, which is possible, but is also questionable for a lot of people, I think.
Yeah, I also think an interesting point there is that it prevents people from, or it helps people from having to digest those pretty steep learning curves where, we all have a pretty full plate of tasks that we need to do, and sometimes learning extra technology that is not your core That's one of the key benefits as well. Another question here is, does Converge DB load data from CSV files?
We don't yet. We focus on the JSON use case because that's really what we're seeing as the most common. But we do, of course, intend to support CSV, Excel, whatever the appropriate file formats that our customers and community need. So really, we're taking the Amazon approach of, putting out a product that works, that has the key core features, but we're going to let the end users drive what do we work on next, right? So if the next thing we need to work on is CSV, we'll focus on integrating CSV. Realistically, with the fact that we're using PySpark, we should be able to support pretty much any input format that PySpark SQL naturally supports. Those would be pretty easy for us to integrate. Any other exotic data sources that you might have beyond CSV, reach out and discuss it with us, because really we can make anything fit it into Converge DB. It's really just about figuring out, should it be in the core code base, or is it something that should sit outside of Converge DB to help you get the data in?
Okay, thank you. So we're quickly approaching our allotted time here. So we got one last question, and then I think that may wrap us up for now. Interesting question here. Why the name Converge DB?
Okay, so convergence is state convergence in particular is a DevOps principle that's really used in a lot of tools. I learned about it years ago using the tool Chef to manage servers in AWS. The idea of convergence is that as you run your code, you're not following, your code isn't just a list of steps to execute. It's a definition for a target for how you want the state of your infrastructure or your application to be. And every time you run the script, it converges closer towards that target state, ideally achieving that target state in one run. So that is the principle of convergence that, I think if you look at the DevOps dictionary, there's a very good explanation of convergence and how it relates to idempotent processing. But, Converge DB also uses this principle, not just because we're using DevOps to deploy it, but this concept of state convergence is actually used in the ETL jobs by way of a what's called a decoupled producer-consumer model, which is a common cloud design pattern, and it's deeply integrated into the design of the ETL as well as the methodologies for deployment. So more information on this is actually on our GitHub page with some links to some reading if you're curious about this.
Excellent, excellent. Okay, so I think that's it. There are no more questions. Good job, Jeremy. So I think we're going to go ahead and just wrap this up. Please take a look at the last slide that we have here, more info, so you can read a little bit more about Converge DB at www.convergedb.com. And then this is also my email ID, so feel free to reach out via email, and love to talk to you guys more about applying DevOps for your data. Thanks.
All right, thanks everybody.